one wants to know. Okay, so today we're going to work on Unit 8B.9. Okay, and today we're actually going to be working on solve log equations. Okay, so we're going to solve log equations today. Okay, like I said earlier, we are going to be testing next week on block day, so we'll finish up this unit this week, and then we'll test next week. Okay, so there are a couple of steps to solving log equations. Excuse me. The first step, step 1, is to condense. Okay, so condense using the properties. Remember, we have those 3 properties, the product rule, the quotient rule, and the power rule. Those are the ones that we're going to be using again. Okay, so those same 3 are ones that are pretty important. We're going to be using those a lot today. Then you are going to drop the log or base, and you'll see kind of what that means in just a second. And step 3 is to solve for x. So there's not a ton of steps here. It should be, fairly simple. Okay, so again, we are going to ask you to solve for x. Solve for x. So for example, number 1, if I ask you to solve log base 2 of 3x equals log base 2 of 96. Log base 2 of 3x equals log base 2 of 96. So first thing you want to do is you want to make sure that there is exactly the same amount of logs on each side. Okay, this one, there's nothing that can be condensed because there's only 1 log on each side. And that's perfect. That's exactly what we want. Once you have the exact same log base on each side, you get to drop those. Okay, so this is kind of like what we did in Unit 8A. So drop the base and set the parts equal to each other. 3x equals 96. Now, the log base does have to be exactly the same, but I'm not going to give you any problems where they're not exactly the same. Okay? Yeah, you're not going to have to worry about that, but they would have to be technically exactly the same. Then we just solve. So to get x by itself, divide both sides by 3, and x equals 32. That's your answer. Okay? Shouldn't be too bad. I know, don't say it just yet. Okay, number 2. We have 8 examples today. 2 multiplied by log base 5 of 4 equals log base 5 of 2x. 2 log base 5 of 4 equals log base 5 of 2x. So when I say condense, we have to have just a log base on each side. So to condense this, how can I move that 2? Make it an exponent, right? So it's like that little power dog. So log base 5 of 4 squared equals log base 5 of 2x. Once you have exactly 1 log base on each side and they're exactly the same, you get to drop them. So they just kind of go away. And then we set these parts equal. What is 4 squared? 16. Okay? We're not rewriting this as any sort of common base or anything. So you're just doing 4 squared, which is 16, equals 2x. Divide both sides by 2, and 8 equals x. If you wanted to, you technically could plug these back in to your equation. You could check your answers. Not that you have to, but you could. Okay, number 3. Let's try log base 6 of 3 to the x power equals log base 6 of 81. Log base 6 of 3 to the x power equals log base 6 of 81. This one, you already have the same log base on each side, so you can go ahead and drop those log bases. So log base 6 goes away. That leaves you with 3 to the x equals 81. Anyone have any idea how you would solve that? How am I going to solve for x? If x is in the exponent, I have to do what? This kind of goes back to what we did in 8A, Unit 8A. Say it again. Not square root. But if you have x in the air, what do you have to do? Get the same base. Okay, so I need to rewrite these as the same base. The base they'd have in common is 3, so 3 to the x equals 3 to what power equals 81? 3 to the 4th. Then we already dropped the log base up here. You're going to do the same thing with this base. Drop it again, and x equals 4. Okay, so it can happen that sometimes you're going to drop the base 2 times, and that's perfectly fine. Okay, so rewrite those. See? What do you mean?
You can tell it when 4.
You mean from right here?
Yeah.
Well, yeah. So you can just write, yeah, that's, I did that, but yeah. Okay, number 4. I'd like you to solve log base 2 of quantity, so that means in parentheses, 3x plus 7 equals log base 2 of quantity, so in parentheses, 4x minus 8. Okay, log base 2 quantity 3x plus 7 equals log base 2 quantity 4x minus 8. Is there anything that needs to be condensed here? No. Okay, these are already in parentheses and there's only one log base on each side. So once you have exactly one log base on each side, drop them. Okay, providing that they're exactly the same, but they always will be because that's the only type I'm going to give you. And then just set the parts equal to each other. So 3x plus 7 equals 4x minus 8. This is just back to like normal solving. So move letters to one side, numbers to the other. If you need to, you can show your work. I'm not requiring that you show every single step here. You probably could do a lot of this in your head. Seriously. So hopefully we should get 15 equals x. Questions on how I did that? Not too bad. Okay. Number 5. Again, I'd like you to solve for x. Log base 4 of quantity x minus 2 equals log base 4 of 25 minus log base 4 of 5. So log base 4 quantity x minus 2 equals log base 4 of 25 minus log base 4 of 5. For this one, is that completely condensed? No. Okay, you can only have one log base on each side. So how can I condense this? What does subtraction turn into? Division. Okay, subtraction turns into division because of the quotient rule. So this becomes log base 4 of 25 divided by 5. Then once you have one log base on the exact same side, or the exact same log base, one on each side, drop those and you can set the parts equal. So x minus 2 equals, what's 25 divided by 5? Not subtract, but 25 divided by 5 is 5. Okay, be careful that you're not actually subtracting those, but you're dividing. Then we're just going to solve. So add 2 to both sides, and we should get x equals 7. That's your answer. Anybody have questions so far? Nope. Okay, this next one looks a little different, but I don't want you to be too thrown off by them. Okay. Natural log. So ln, natural log, quantity x minus 2. Or sorry, I'm looking at the wrong question. Natural log, quantity 2x plus 3. Not bad. Minus natural log, quantity x minus 2 equals natural log 4. Okay, all this means is this is log base e. Okay, nothing changes about how we're working this out though. Okay, nothing at all is going to change about how you do this problem. So to condense, you would need to have one natural log or one log base on each side. How can I condense this subtraction problem? Division, right? So natural log, this is going to become 2x plus 3 over x minus 2 equals natural log 4. Now, this is log base e, or natural log. Each one, there's one on each side, so you can drop them. Okay, you don't have to do anything special at all with those. Then we set the parts equal to each other, so 2x plus 3 over x minus 2 equals 4. How do we solve that? Any ideas? What?
Conjugate?
No, this has nothing to do with the conjugate. That's imaginary numbers. Any ideas? How do we solve if something's equal to a fraction? Say it again. Kind of like the reciprocal. You want to make this a fraction. Okay, so make it a fraction to make it over 1, and then we're going to cross multiply. Okay, so cross multiply. If you cross multiply 2x plus 3 times 1, you just get 2x plus 3. Okay, so that's fairly easy. Equals, if we cross multiply 4 times x minus 2 gives you 4x minus 8. So distribute the 4 all the way through. And then just move numbers and letters to opposite sides. Doesn't really matter which way you move them, as long as you get numbers on one side, letters on the opposite side. And then solve. So this is just back to inverse operations that you did in like pre-algebra or maybe algebra 1. And then divide. You can get fractions, and that's okay. As long as they're reduced, you can leave them just as fractions. Okay, so no, you don't need to rewrite it as a mixed number or anything. That's your answer. Questions on how I did that? Nope. Okay, almost done. 2 more. Number 7. Again, I'd like you to solve log 3 to the 2x power. Log 3 to the 2x power equals log 27. Log 3 to the 2x power equals log 27. Sorry, that's a really ugly 27. Here comes the broke halfway. So, does anything need to be condensed? Nope, you already have one log base on each side. What's the base? Base 10. Okay, the base is 10. It's not written there, but it is the same on both sides. Then you want to set these parts equal. So 3 to the 2x equals 27. What do we do if we have an exponent? If your x is in the exponent. Get the same base. So what base would these have in common? Base 3. So 3 to the 2x equals 3 to what power equals 27? 3 cubed. Then drop your base again and set the exponents equal to each other. Just solve, do the inverse operation. So divide both sides, and x will equal 3 over 2. Okay, last one for number 8. Okay, this one's probably the most difficult, but that doesn't mean that it's not something you could do. So log base 7 of x equals 2/3 log base 7 of 27 minus log base 7 of 5. Log base 7 of x equals 2/3 log base 7 of 27 minus log base 7 of 5. You guys try that one on your own. It's fine, try that one on your own, and we'll hopefully be able to come up with the same answer. So first thing you want to do when you're condensing is what? Should I deal with the exponent or with the subtraction? The exponent. Okay, so we're going to rewrite this. The exponent only goes to the 27. This is going to be log base 7 of 27 to the 2/3 power minus log base 7 of 5. Okay, you can simplify that first or next, doesn't really matter. Log base 7 of x equals log base 7 of, if you want to rewrite this, okay, we're going to rewrite this in power handle. So 27 power of 2 handle of 3, and that subtract turns into a divide bar. Then if we have log base 7 on each side, you can drop those. And you're going to get x equals, what's the cube root of 27? 3. It's going to be squared over 5, and what is 3 squared? 9. 9 over 5. And as long as it's reduced, which that is, that's your answer. Where'd I lose you guys? So power handle, so cube root is 3, and then take it to the power. So 3 squared is 9. Okay, homework for this is going to be worksheet 9. We're working on worksheet 9, numbers 1 through 15. Okay, worksheet 9, 1 through 15.